Picture this: Cape Kennedy, Florida, January 27th, 1967. Three astronauts are strapped inside a spacecraft on the launch pad, but this isn't a launch. It's just a test. A plugs-out test where Gus Grissom, Ed White, and Roger Chaffee run through countdown procedures to make sure the command module can operate on internal power. The cabin is sealed and pressurized with pure oxygen at 16.7 psi, because that's NASA's standard protocol for Apollo missions. Simple, lighter, easier than a mixed gas system. Beneath Grissom's seat, electrical wiring insulation has worn through from repeated testing. Exposed copper wire touches the metal frame. A spark jumps. In normal air, this would be a small electrical fault. In pure oxygen, it's a detonator. The cabin erupts into an inferno. Flames spread across Velcro, nylon netting, and foam padding materials that don't burn in regular air but become explosively flammable in pure oxygen. The temperature hits 2,500 degrees Fahrenheit in 17 seconds. Grissom shouts, "Fire!" Chaffee reports, "We've got a fire in the cockpit." Ed White in the center seat immediately starts opening the hatch, but there's a problem. The hatch opens inward. As fire consumes oxygen and releases gases, cabin pressure spikes, pinning the hatch shut with thousands of pounds of force. They can't open it from inside. The pad crew can't open it from outside. The three men are trapped. 17 seconds after the spark, communications go silent. The pressure ruptures the hull. Flames burst out, driving rescuers back. 5 minutes later, technicians force the hatch open. All three astronauts are dead. The autopsies show they died of asphyxiation from carbon monoxide and toxic gases. The burns were severe but survivable. What killed them was the atmosphere NASA chose for simplicity. Engineers had warned about pure oxygen risks. Previous tests showed materials becoming combustible in oxygen-rich environments. The command module was packed with over 70 feet of Velcro and flammable padding. NASA knew. They accepted the risk because the moon landing schedule was non-negotiable. The agency was operating under go fever, the pressure to beat the Soviets no matter what. Grissom, White, and Chaffee died on the ground in a test because meeting deadlines mattered more than fixing a system engineers knew was dangerous. Apollo was grounded for 18 months. The command module was completely redesigned with fire-resistant materials, an outward opening hatch that could release in seconds, and a nitrogen-oxygen mix for ground tests. 3 men burned to death so NASA could learn what engineers already tried to tell them. April 24th, 1967. Vladimir Komarov is falling from space in a Soyuz capsule with no working parachutes. The main chute failed to deploy. The reserve chute tangled with the drogue. He's in free fall at terminal velocity, and everyone listening on the ground knows he's about to die. According to later accounts, Komarov spends his final moments cursing the engineers and politicians who sent him up in a spacecraft with over 200 documented unfixed problems. The capsule hits the ground so hard it crumples. Then, the landing retro rockets, designed to fire before touchdown, ignite on impact, and incinerate what's left. Komarov becomes the first human to die during a space mission, and the cause isn't a surprise failure. It's the inevitable result of launching a man in a vehicle engineers explicitly warned wasn't ready to fly. The problems weren't hidden. By spring 1967, engineers had documented over 200 design flaws in Soyuz. The systems were unstable. Critical testing was incomplete. Soviet officials Dmitry Ustinov and Leonid Smirnov demanded the mission proceed anyway because it was timed for the 50th anniversary of the October Revolution. The spectacle mattered more than safety. The mission plan was absurdly ambitious. Komarov launches solo, then Soyuz 2 launches the next day, with 3 cosmonauts who will rendezvous, perform a spacewalk transfer, and swap crews. Pure propaganda theater. Engineers protested. Reports suggest Komarov knew the spacecraft was a death trap, but felt compelled to fly because refusing meant his backup, Yuri Gagarin, would be sent instead. The decision to launch wasn't technical, it was political. From the moment Soyuz 1 reaches orbit, failures cascade. One solar panel won't deploy, cutting power in half. The attitude control system malfunctions because thruster exhaust interferes with the ion sensors, leaving Komarov unable to point the spacecraft reliably. Soyuz 2's launch is cancelled. Komarov is ordered to return immediately. He manually aligns for re-entry despite the broken systems and survives the heat of atmospheric entry. The descent starts normally. The drogue chute deploys to slow and stabilize the capsule. Then the main parachute is supposed to extract and open. It doesn't. The container deformed during re-entry heating, and the drogue can't generate enough force to pull the main canopy out. Komarov, recognizing he's in uncontrolled free fall, manually triggers the reserve chute. It deploys but immediately tangles with the drogue, which failed to separate. Both parachutes are now useless fabric balls. The capsule falls with no aerodynamic braking. Komarov hits at hundreds of kilometers per hour. The kinetic energy shatters the structure. He dies instantly from blunt force trauma that liquefies organs and pulverizes bone. Then the retro rockets fire, setting the wreckage ablaze. Recovery teams find a charred, compacted ruin. The remains are so destroyed the funeral uses a closed casket. The Soviet space program grounds all crewed flights. Soyuz undergoes extensive redesign. The moon program, already behind, is delayed another 18 months. Vladimir Komarov died because a political anniversary mattered more than 200 engineering problems. 168 kilometers above Earth. June 30th, 1971. Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev have just spent 23 days aboard Salyut 1, the world's first space station, completing a record-breaking mission. They've transferred back into the Soyuz descent module, sealed the hatch, and initiated separation. Pyrotechnic charges fire, violently severing the orbital and service modules. The shock jolts a pressure equalization valve open. That valve is supposed to open at low altitude where outside air is breathable, not at 168 kilometers where the environment is vacuum. The cabin, pressurized to sea level, begins venting directly into space. They're not wearing pressure suits because Soyuz was redesigned to carry 3 cosmonauts instead of 2, and there wasn't room for 3 men in 3 bulky suits. They have maybe 2 minutes to locate the valve hidden under Dobrovolsky's seat and manually close it before losing consciousness. They fail. All 3D of hypoxia as the capsule automatically completes its descent and lands perfectly on target. When recovery teams open the hatch, they find 3 men still strapped in their seats, motionless, dead. They are the only humans to ever die in actual space. The valve that killed them was a design feature meant to equalize cabin pressure with atmosphere during final descent, preventing dangerous pressure differential at landing. It was engineered to open at low altitude, not in near vacuum. The violent pyrotechnic separation triggered it early. There was no warning system, no indicator, no alarm. The valve location beneath the seat made quick access nearly impossible. And the fatal trade-off, no pressure suits because Soviet designers chose crew capacity over individual life support. That choice killed 3 men. The valve opens, cabin pressure drops rapidly. The cosmonauts have between 60 and 110 seconds before unconsciousness. Patsayev's biomedical sensors show his heart rate spiking then plummeting. 50 seconds after the valve opens, his pulse crashes. Evidence shows Dobrovolsky unbuckled and tried reaching the valve, but the location, decompression speed, and no suits made survival impossible. At 110 seconds, all 3 lose consciousness. Blood pressure collapses. Dissolved gases in their blood form bubbles, causing decompression sickness. Oxygen stops reaching their brains. They're dying of hypoxia, starved of breathable atmosphere. The Soyuz, operating on automated programming, continues perfectly. Parachutes deploy on schedule. Soft landing rockets fire precisely. The capsule touches down gently in Kazakhstan. Every system works flawlessly. The crew is dead. Recovery helicopters arrive, expecting to extract 3 cosmonauts fresh from a record mission. Teams open the hatch and find 3 motionless men with blood in their noses and ears. Classic signs of rapid decompression and vacuum exposure. Autopsies confirm asphyxiation from hypoxia, with internal hemorrhaging consistent with sudden exposure to near vacuum. The Soviet program suspends all crewed flights immediately. Soyuz undergoes major redesign, reverting to 2 cosmonaut configuration to allow mandatory space for pressure suits during all launch and re-entry phases. Fewer crew per flight, but every crew member has personal life support for cabin decompression. Dobrovolsky, Volkov, and Patsayev died to prove pressure suits aren't optional. Their survival requirements. 73 seconds after launch, January 28, 1986. The Space Shuttle Challenger is climbing through 46,000 feet over the Atlantic. Everything feels normal to the crew. Then the right solid rocket booster breaches, sending superheated gas directly into the external tank, holding over 500,000 gallons of liquid hydrogen and oxygen. The tank ruptures, propellants mix and ignite. A massive fireball engulfs the vehicle. Challenger, subjected to aerodynamic forces it was never designed to withstand, breaks apart. The crew cabin separates relatively intact and continues upward on momentum, arcing to 65,000 feet before falling back toward the ocean. Commander Dick Scobie, pilot Michael Smith, mission specialist Judith Resnick, Ellison Onizuka, and Ronald McNair, payload specialist Gregory Jarvis, and teacher in space Krista McAuliffe have nearly 3 minutes before impact. Evidence recovered from wreckage shows at least 3 crew members manually activated emergency oxygen packs, which means they're conscious, aware, and completely helpless as the cabin falls at over 200 miles per hour. There's no escape system, no ejection seats, no survivable outcome, and the disaster isn't a surprise. Engineers warned NASA the night before that freezing temperatures would compromise the rubber seals in the booster joints. Management overruled them and launched anyway. The technical cause was O-ring seal failure in the aft field joint of the right solid rocket booster. These rubber O-rings prevent hot combustion gases from escaping joints between booster segments, but rubber loses flexibility in cold. Launch morning temperatures were in the mid-20s Fahrenheit, far below the O-ring's certified range. Engineers at Morton Thiokol held a teleconference with NASA the night before and explicitly recommended scrubbing the launch. The data was clear. Cold temperatures dramatically increased O-ring erosion risk, and previous flights already showed heat damage to seals. The O-rings were criticality 1, meaning failure results in loss of vehicle and crew. Despite this and mounting evidence, the issue had been normalized as acceptable risk rather than treated as the design flaw it was. NASA management, facing intense schedule pressure, challenged Thiokol's recommendation. Thiokol and management overruled their own engineers and approved launch. Schedule pressure overrode explicit safety warnings backed by data. The boosters ignite. Immediately, cold, stiffened O-rings fail to seal the aft field joint. Hot gas begins escaping. The flame starts small, but grows as the joint flexes under thrust. At 58 seconds, the plume visibly burns against the external tank. At 72 seconds, the tank structure fails. Liquid hydrogen streams out and ignites. At 73 seconds, the tank explodes. The shuttle stack disintegrates. The orbiter's wings and tail rip away from aerodynamic forces. The crew cabin, structurally reinforced, separates and continues upward, reaching 65,000 feet before falling. The crew is likely alive. Post-accident analysis showed at least 3 personal egress air packs manually activated. These require conscious action, meaning at least 3 crew members survived initial breakup and reached for emergency oxygen. For nearly 3 minutes, they fall, strapped in seats, aware, with no escape and no survivable outcome. The cabin hits the ocean at terminal velocity. Deceleration forces are instantly lethal, measuring hundreds of Gs. Seats and restraints fail catastrophically. Every crew member suffers fatal blunt force trauma. Bones shatter. Organs rupture. Death is instantaneous. The Rogers Commission concludes the technical failure was the O-ring, but the systemic failure was NASA's management culture normalizing known hazards and letting schedule override engineering judgment. The shuttle program grounds for 32 months, while booster design is revised and safety oversight rebuilt. 16 minutes from landing, February 1, 2003. Commander Rick Husband and pilot William McCool are guiding Columbia through re-entry after a 16-day science mission, traveling Mach 18 at 207,000 feet over Texas. Everything appears normal until sensors in the left. Wings start failing. Tire pressure readings go wrong. McCool radios mission control about the unusual data. Before he finishes the transmission, flight computers detect catastrophic loss of aerodynamic control. The left wing's internal structure is failing, melted through by superheated plasma burning through a breach in the thermal protection system for 15 minutes. The breach was caused 16 days ago during launch when a briefcase-sized piece of foam insulation broke off the external tank and struck the wing's leading edge. Engineers saw it happen. They raised concerns. They requested satellite imagery to assess damage. NASA management denied the request, categorizing foam strikes as maintenance issues, not safety threats. The crew Husband, McCool, mission specialists Michael Anderson, Kalpana Chawla, David Brown, and Laurel Clark, and payload specialist Elon Ramon were never told there was concern about wing damage. No contingency planning happened. Now the wing is failing at hypersonic speed. The orbiter begins rolling uncontrollably. Extreme forces tear the vehicle apart. The crew has approximately 30 seconds of consciousness before forces become unsurvivable. 17 years after Challenger, identical organizational failures killed another crew. During launch on January 16th, engineers reviewing footage identified the foam strike and immediately raised concerns about thermal protection system damage. They formally requested Department of Defense reconnaissance satellites image Columbia's wing and assess the breach. NASA management denied it. Foam shedding occurred on previous missions without catastrophe, so the hazard was downgraded from critical to routine. This was textbook normalization of deviance. A known anomaly observed repeatedly, gradually accepted as normal rather than treated as the design flaw it was. Foam strike problems were documented for years. Columbia's crew was never informed ground teams had concerns. No contingency plans developed. No rescue options explored. The mission continued while evidence of potentially fatal breach was actively ignored. Re-entry begins normally over the Pacific. As atmospheric density increases, the damaged left wing heats beyond design limits. At 8:50 a.m. EST, superheated plasma penetrates the breach, gas heated to thousands of degrees that melts aluminum wing structure from inside. Temperature sensors fail as structure burns. At 8:53 a.m., unusual tire pressure readings appear. McCool radios mission control. Mid-transmission, computers detect loss of control. The left wing, internal structure compromised and burned through, fails aerodynamically. The orbiter begins rolling. Aerodynamic forces rip the vehicle apart. The crew cabin separates and tumbles while depressurizing explosively. They're wearing pressure suits but inadequate for the forces. Violent deceleration, extreme wind blast, thermal stress from atmospheric friction. Recovered. Helmet debris shows. At least one crew member actively attempted restoring systems, switches in positions indicating conscious manipulation for approximately 30 seconds after breakup alarm. Then forces exceed human tolerance. Consciousness ends. The cabin breaks apart, scattering debris and remains across Texas and Louisiana, all 70 during breakup. The Columbia Accident Investigation Board determines structural disintegration occurred in a flight regime where survival was impossible regardless of crew action. The cabin wasn't designed to remain intact during catastrophic failure at hypersonic velocities. Pressure suits and restraints proved inadequate against extreme kinetic and thermal forces. The final report is devastating. NASA failed to learn Challenger's lessons, repeated identical management failures, and ignored explicit engineering warnings about foam strikes for years. Foam debris strikes occurred and were documented since early shuttle flights, but were progressively normalized as acceptable rather than addressed as design defects, demonstrating the organizational culture responsible for Challenger never actually changed. The shuttle grounds for 2.5 years, operates under increased safety constraints until final retirement in 2011, replaced by capsule vehicles with launch abort systems. The safety architecture shuttle lacked that might have saved 14 lives across 2 disasters, 5 missions, 21 deaths. Apollo 1 burned 3 men alive in pure oxygen during a ground test. Soyuz 1 crashed when 200 known defects weren't fixed before launch. Soyuz 11 depressurized in space because crew capacity mattered more than pressure suits. Challenger launched on frozen O-rings after engineers explicitly said don't fly. Columbia disintegrated during re-entry because foam strikes were normalized as routine. 3 of 5 disasters resulted from management overriding engineering warnings. 2. Resulted from known design flaws accepted as operational risk. Every death was preventable. Space doesn't kill astronauts. Organizational cultures that prioritize schedule, politics, and normalization of documented hazards over safety kill astronauts.